Okay, so we'll continue our conversation on inheritance. The example we've gone over so far, just as a refresher, we have a class called circle. We're defining a circle as having an x-coordinate, a y-coordinate, and a radius length. Like I said, doubles can take on negative values, so there's a little bit of a problem with mathematics here. We could actually put a negative value in the radius, but that's okay. This is good enough just to get the point across. Then we decided, when we begun talking about inheritance, we decided to create a class called graphic circle, which is it is a circle, but it has extra properties to it. The extra property is that it has an outline and a fill. So it's the color of the outline, and then what color should be inside the circle. Now, if you think about it, we could extend this even further and have like a circle with a thick out, you know, how thick the thickness is. We could add another field if we wanted to. So there's really no limit to what we can add to it. But what we're doing here when we're extending, it is like we are taking all the data fields and all the methods. And there's no methods in this one right now, except for the default constructor, which we talked about. We're taking all the data and all the methods, and we're getting them all for free, just by saying extend circle. It's like the x, the y, and the r are already written here. It's like we had this. If I had double x, y, and z, and took out the extends, that would be the same thing. So basically getting everything that's up here for free. Okay. So now if we want to declare one of these variables, if we decided later on we wanted to declare a graphic circle, we could do this. We could say graphic circle. GC equals new graphic circle. This means run the constructor that takes in no parameters, the default constructor. Run that constructor, create an object, and have GC refer to it. Now, do you see in this graphic circle class definition, do you see the constructor that's being called? Do you see a method here that has the name graphic circle and takes in no parameters? You see one written here somewhere. Right, there isn't one. So does that mean it's not there, or it won't be called, or we'll have a compiler? Or what happens if you don't have the constructor method? If you didn't define one, there is one that is given to you by the compiler for free. And what does that one do? Well, it takes in no parameters. And then what it does is it just fills in the fields with default data. So let's just think about what is the default constructor at this point. The default constructor, it was like, I'll write it in blue. It was like we had a function called graphic circle, no parameters, open paren. What does a constructor do automatically? The very first step it does, if you don't do it explicitly, what would it do? We talked about last class. We said it will automatically call the constructor of the class it inherits from. And if you don't inherit from anything, you automatically, in Java, you automatically inherit from the class object. So the default constructor, the first thing it does is it calls the constructor of the class above it. Super, with no parameters. If you don't want the one with no parameters, and remember we had a few constructors with circle. We had the one that takes in no parameters, which gave us a default circle. I think we decided the default circle would be x is 0, y is 0, r equals 1. Okay. So if you created a circle with no parameters, you'd get the default one. We also had a constructor that had x, y, and r where you could pass those in. You could set the circle to be centered somewhere, and you can make the radius whatever you want. if you don't give for graphic circle, which extends from circle, if you don't supply a constructor, the compiler will generate one for you automatically. And it is exactly like as if you wrote this. If the constructor that takes in no parameters, the first step is to call the superclasses constructor with no parameters. And then the next step is to fill in the new fields with default data. So that would be outline equals, and did we have, oh, we said black was the default, and fill equals white. So the fact that we did not supply, when we wrote the class in red, the fact that we did not supply a constructor, the compiler gave us what's in blue for free. If we don't like what's in blue, here's our opportunity when we're creating the class. Here's our opportunity to come up with something else. But if you don't say anything, you get whatever the default is. The default is always, first you call the superclass circles constructor with no parameters, and then all of your fields get filled in with default data. That's what you will get if you don't supply one. Generally, we like, maybe that's what we want. Sometimes it's not. Like, for example, we talked about if you had a ratio with a numerator and denominator. If you don't supply a constructor, they'll all be created with a numerator of 0 and denominator of 0, and that's not good. So we would like to make our own constructor and make the denominator equal to 1. So the constructor is optional. If you don't supply it, everything gets filled in with default data. And if you don't like the default data, then write a constructor and fill in the fields however you want them filled in. Okay. So now, suppose we decided, and you could see this happening in the real world. Suppose we decided that we wanted to have a new variable for the graphic circle, maybe a variable for resolution, like how bright or dim the circle is. Like maybe on a scale from 1 to 10, we can have resolution. Suppose we went and did this. We added a new field for resolution, but we happen to call it the same variable as the radius. The reason why I say this could happen is we might buy this class from some software company, and then we add our own classes below that. And we don't even know what is in their variables. Right now we can see it, it's all on the board in front of us. But sometimes we might not even know the names of the variables they're using. Or we might just forget and happen to use the same letters. So now suppose we had a variable, this R is for the radius. This R is for the resolution. Well, if we created an object and it called its default constructor, which made the 0, 0, 1. Oh no, sorry. Oh, for example here, it's a bad idea for us to not supply a constructor, because what would happen if we created a graphic circle, like the constructor we just had up, would call the constructor of a circle with no parameters. So it would be good for us to have supplied, and I think what we did when we created this class was we had a constructor that takes in no parameters and made the radius 1, because that's the one that would end up getting called. Okay, so now we've created an object, GC. We created an object GC. And it turns out now this object has 5 fields to it. It has an X, a Y, a radius, 6 fields, an outline, a fill, and a resolution. Now it looks like if we don't supply a constructor, the resolution, since it's an integer, the resolution by default is going to be 0. So where it would end up, this line right here would create a graphic circle call the graphic circle constructor, which is not here. So that will, by default, call the graphic constructor for a circle that takes no parameters, which will fill in. Maybe I should have wrote it. Let me write in the circle default constructor. X equals 0, y equals 0, r equals 1. That's what we said would happen by default. If you created a circle and didn't give any information, we'd have an x 0, y 0, and r equals 1. So this would do this. It would call the supers. When you go to create a graphic circle, you go and call the constructor of the graphic circle. There isn't one, so by default, it has the lines where it calls the constructor of a circle that takes in no parameters. That fills in 0, 0, 1. That's what these are. And then it goes and fills in these three fields with default data, which would be black, well, we never defined what the default values of these are. So default colors, I don't know, what do you think the default color is? If you just had a field, because this is, again, this is a field that we created. It's not one, it's not a primitive type. So if there was such a thing as a default color, I don't know what, maybe clear. Or no fill, is that considered a color? Or no fill? And then R would default to 0 because we didn't explain what to do with the resolution. So this would be what would get constructed. Now here's the problem, we have two fields named R. So if we then decided to use this object, gc.r equals 4, we decided to assign 4 to the R field. Which R field would get assigned 4? Now again, for us to be able to do this, these fields would have to be public or in the same package, and we'll talk about that a little later on. But let's just say for right now, we are able to assign to this field R. We have permission to assign to that field R. Which of the two R's would you think it would get assigned to? Would it be the resolution? Is this line setting the resolution to 4 or the radius to 4? So what we did was we have a field from circle called R, and we added a new field for resolution called R. And this is going to cause some confusion. So which one are we talking about? Or which one do you think it would be?
I think resolution.
Because that's like the newest one?
Yeah, because you call it graphic circle.
Right. Well, so this is a graphic circle. So a graphic circle does have two R fields.
Right.
One for the radius and one for the resolution. Right now, we're not explicitly saying which one it is. We're just saying take this chunk of storage, go to the field called R, and fill in a 4. Which one are we going to? We're going to this one or this one? Yeah, there's probably a few choices. If you were designing the language, would you let it be the first one? Would you let it be the most recent one? Like, it sounds like you're saying because a graphic circle added an R, that's probably more what it means.
Can I do to both the fields, like both R's? Like
at the same time?
The R, then it fills 4.
You mean put a 4 here and a 4 here?
Yeah. Get it?
Well, that would be a problem. What we'd like to be able to do is be able to refer to both fields. We'd like to be able to set the radius to one number and the resolution to another number. So we wouldn't want it to write to both fields simultaneously, because then we could never make them different. And we could explicitly say, I want the R that came from the class or the R that came from the graphic circle. But right now, we didn't explicitly say which one. So if you were designing the language, what would you let? Would you let this be? Would you make this a compiler error and tell the person, please explain which R you mean? Would you have a default?
I would have a compiler error.
Okay, because they're not being clear.
Yeah.
Which one? Okay. Well, there are ways to refer to the object if you are within a class method. You could say, we could use the this operator. We could say, we could go like this. We could say this. Now remember, this is a reference when you're inside a class method, not to the external world. But you could say this R equals 4. That would mean we're talking about this whole thing is referred to as this. And that means the one that is most recently added, the R that was most recently added. If we said the super dot R equals the rate R equals 2. If we said that, then the first one did make this a 4. If we say super dot R, that's a dot. If we say super dot R equals 2, we're saying the superclass, which is really this section. This is super. Only these three is considered the super component, the superclass component of the circle. That's the X, the Y, and the R. If you say the super's R is 2, you're actually doing this. You're making that part 2. And if you just left it alone and said R, your choice of compiler error could be good because there is confusion. You don't know which R it is. But they decided by default to let it be to this pointer. So this is the same as making this a 4. Okay, so now the only twist that we're adding here, we've already talked about inheritance using extends. We've done that before. Now we've just added confusion in that the variables have the same name. Two variables have the same name. So we definitely want to be able to refer to each field. We have this opportunity. We could say that this pointer is for the overall object, and then the super is the superclass's version of the variable. Which then means we could have said this, right? We could say super x equals 1. What does that do? Changes this to a 1. Right? We're saying go to the superclass and then find its x field. But we didn't need super. This is actually optional. Right? Because there's only one x. If I said take this object and makes it x field equal, there's only one x, so there's no confusion. We don't need super. Super was needed for this one. To get to the radius, we'd have to say super. Okay? But there's another way. Now let me just take a little time out. If you have, let's take a little time out from this graphic circle thing. If we have a floating point, this is a topic called casting a variable. We have a floating point called f equals 3.5. And we have an integer, I. And then we say I equals f. Now, we chatted about this last class, and I did find out what the answer is in Java. It's a different answer in C++ than it is in Java. What happens here? So if you were designing the language, would you either A, would you allow this to go through, which would then mean, and if so, what would you round this up or down? What would you do? Or B, would you let it be a compiler error, saying, I don't know what it is you're trying to do, or I might lose some data that you care about, so would you, we're trying to assign 3.5 to an integer, so we can't have any decimals.
Yeah, I think we would make a compiler error, just because of the reason, because sometimes we need the exact answer, and if we round off, so, we might be a little off on the right answer.
Okay, and that's what you would end up doing if you were designing the language? Make it a compiler error? So then what if somebody wanted to do this? They go, you know, let's say f was some floating point, they've been calculating something for a very long time, but for some reason they need to store the result finally into an integer. And they don't mind if they lose the decimal point or round off or something like that. It's a good idea to make this a compiler error because the person might not have realized these types are different. I'm using the letter F and I so we kind of can see with our eyes, this is a float and this is an integer, but this could have been some variable like size of the rectangle, you know, could be anything, and you don't really remember it's a float or an integer. So it might be a good idea to have this be a compiler error and make the person, you know, aware, hey, understand these types don't match. But what if you did need this to go through? You have to somehow develop, the software program would have to say, all right, I know this is a floating point. I know this is not an integer. And I'm trying to write it into an integer, and I want you to do it. So that way the compiler can say, all right, if now you're responsible, not the compiler being responsible. So you would make this a compiler error. Actually, in C++, this is not a compiler error. This will go through, and the decimal will be lost. So actually, maybe a better example would be 3.9. In C++, I would become, you might think 4, you might think it gets rounded up. You might think it's 3, or you might think it's a compiler error. In C++, it would become 3. The decimal is lost. But the creators of Java came out about 10 years after C++, they decided to do what you're saying, make this a compiler error. If you just try to put, if something gets lost, now what if it was the other way around? What if it was like this? This is a little side conversation, but the same topic comes up here. What if you said this? You're trying to take the 2 and write it on top of a floating point. Would this be a problem? Would you say type mismatch? This is not a problem. So this would become 2.0.
Right.
And you would give no warning, you just say that's fine. Okay, that's what they ended up doing. So they decided if something gets lost, they're going to make it a compiler error. But if something does not get lost, then it's not a compiler error. But there is a way for you, the software developer, to say, I know this is a float. I want it to be converted into an integer. So please do it for me and don't let it be a compiler error. And if you were making up the syntax, how would you do that? So we're trying to do this. We're trying to say I equals F. So I'm going to write something here that involves F, but I want to somehow say, convert this into an integer. You know, don't let it be a compiler error. Convert this into an integer. I know it's not an integer, but try your best to convert it into one. If you were coming up with a syntax, with anything off the top of your head you would do?
Would it just be in parentheses?
Yeah, obviously you saw it before, but if you never saw it, it would be, you might think something like convert to int, and then you might think something like this. There might be a function convert to int, and then you would pass in an f. You might expect to see something like that. This is the software developer's way of saying, I know this is not an integer. Please convert it into an integer and store the result here. So the shorthand is this one. You just write the type in parentheses that you would like to convert it into, and it gets converted into. Okay, so this is just called casting, where you change the type from one to another. Now what if this was something that the compiler could never figure out how to do the conversion? Suppose this was a circle. You're trying to take a circle and convert it into an integer. What could the compiler do then? A circle has 3 fields, an x, a y, and an r. The compiler has no idea that x and y are the x and y coordinates of the center of a circle and the r is the radius. It has no idea what that is. It just has 3 fields. Could it take 3 doubles and convert it into one integer? Add them all up, or add 2 up, divide by the third one? What could it possibly guess? If you tried this, what would you expect to happen? I'd be really stunned if it knew what to do. I think this would be a compiler. You're trying it?
Yeah.
Well, let me know if
It's
it's,
a compiler error, don't worry.
okay. Because the compiler's going, come on, I don't know how to convert a circle into an integer. So when you do a typecast, it better be something the compiler can pretty simply figure out what you're doing, like get rid of the decimal or. But another thing that typecasting we can do is when there's inheritance. We could do this. We could say, take the object we're pointing at and convert its type into the superclass. So we could do this. We could say this, well, let's see, we could say circle this. That means take this pointer and convert it into a circle, and then take its x field. I'm sorry, take its r field. And say that's equal to 2. This would syntactically work. So we're taking this reference, that refers to this whole thing, and then we're saying take this object, which is of type graphic circle, and convert it into a circle. Now, would you allow that? Would you allow that conversion, or would you say, I can't figure out what you're doing? So it's a type, we're converting a graphic circle, which has 6 fields, and they're set to 0, 0, 2, no fill, form. And we're converting it into a 3-field object with a 0, 0, and a 2, and these 3 fields just get lost. Would you allow this? Would you allow this typecast?
No.
Because you can't figure out how to create the new object. See, like in this case, we had an integer and a float, 3.5 and 2. When we, yeah, this is actually a bad example because we're saying anytime something gets lost, we don't do a conversion. But if we said this, f equals I, you'd have a compiler error because we're going to lose the 5. Now in this case, would you let this thing get converted to that? And I guess intuition would say no, because stuff's going to get lost. These 3 fields are going to get lost, right? But this, allowing this will actually get into the next topic we talk about is polymorphism, is where objects change their form, and we would be able to convert this object into this and then convert this one back. So it's like these fields are tagging along, but we won't be able to reference them. So what would your argument be for not allowing this? Because it is a good argument. If you think about this one and then say, can I do this one? What would your argument be? It would be that something's lost. So wait, you said you wouldn't allow this?
No, I'd allow it.
Oh, you would?
You want to know why?
Okay, well, does anyone think you should not allow it? In this case, we didn't allow it. We had a compiler error because we were going to lose the 0.5. We don't want to lose anything. And an integer can't hold a decimal. So if we did this, if we said f equals I, and then
You would move the resolution.
if we moved it back, I'm sorry. If we did this, I equals f, f equals I, and we allowed an implicit typecast, the 3.5 would become 3, and then the 3 would get copied here. Would this go back to being 3.5? No, it would become a 3. You would think these two operations should have, f would go back to what it was, but we lost something because of it. I is of a different type. If you follow the same argument, could we would this be allowed? Would you allow an object of a 6-field type be converted into a 3-field type where the top 3 fields are its base class? Would you allow it or not allow it? And like, what's your intuition? If you don't allow it, what would your argument be? So would you allow this reference to get converted into a circle reference? A graphic circle reference get converted into a type of circle reference. From that point on, you can't refer to outline, fill, or this second R unless you converted it back. And if you converted it back, would these fields show up again? So that, like, this analogy doesn't perfectly map to this one. But why would you say you would allow this?
Because by declaring that a graphic circle extends circle, you're really saying a graphic circle is a circle. So if you want to convert it to a circle, it still can be a circle and therefore should be able to act as a circle and perform all the behaviors that a circle does.
Okay, what if we decided to take this thing and convert it back to a graphic circle? Would that be allowed?
Yeah, because A, if it was a conversion for the first time, you can just give it the default values. I'm not sure how it works if you're converting it back, if those values get stored somewhere.
Well, even those values would still be there. It would just mean as a type, we can only refer to the first 3 fields. So actually, these other fields are still there. So that's why this 3.5 is not a perfect analogy. This 0.5 would be lost forever. If we moved it over here and then copied it back, the 0.5 would be lost. These bottom fields are still there as far as this object is concerned. What ends up happening, and this is like, it sounds a little confusing, but it's a very powerful tool. If we take the type of a graphic circle and convert it to a circle, even though the object is a graphic circle, but we're referring to it with a circle reference, we can only refer to the first 3 fields, but the other fields will be there if we ever change the type back. So what this extends into is we could make an array of circle references. And maybe we have many different types of circles, but we can have an array of circle references and they can refer to all the different types that there are, and then we could later convert them back. So that's going to end up being a pretty powerful type conversion thing that's allowed. So the answer is that you can do that. You can extend them. So I just want to be a little bit careful about using this intuition here. We're not actually losing anything by changing its type. We're just changing what fields we can refer to. So when we change the type to circle, we can only refer to X, Y, and the radius R. We couldn't refer to these. So we couldn't do this. This would be a compiler error. If we said, take this, convert it to circle, convert its type to circle, and then fill equals red. That wouldn't work because this is of type circle now, and circles don't have a fill. Even though that this pointer was pointing at something that had a fill, we converted its type to circle, and now it doesn't have a fill. Okay, so that's an example of where we have a variable called R in circle, and then we have a variable called R also in the class that extended from circle, and there was some confusion about how to refer to the variable. Now suppose we had another just quick example. This is where a method name is going to have the same name too. So we have class A, which has an integer I equals 1, and then a function f, which returns I. And that's that class. And now we have a second class, B, which extends A, it has its own integer, I, which equals 2. And it has its own function, just to make it a little more gravy, which says I equals super dot f plus I. Return super dot f plus I. Okay, so suppose you were given this on a quiz or a job interview or something like that. It's one of these follow what's going on. So what is going on? Let's see. So if we create an object of type B, type, we'll make a little b equals new b. And then we call the f function on b. What would it return something? So it returns an integer. X equals b's f. What would x become? So this is the class definition, and then this is somewhere in your main routine. I think this one's pretty straightforward. So, what's happening? We're calling the object B. The object B has a field in it called, first of all, how many fields does object B have? Object A has a field called I, which we set to 1. And it has a function called f, which returns I. Class B gets everything A has to offer for free. And then in addition to that, it has a field called I, which we set to 2. And in addition to all the functions we got from A, we have another function called f, which does this stuff. So now, what does this return? We call object B's f function. That would be this function. What does it do? It takes the I field. Which I field?
Super, the one in the base on
The one in B?
A. Because super is...
Well, no, okay. So wait, so first of all, if I wanted to draw the storage for a B object, how many fields? So the storage is not, the functions don't take up storage, it's all the variables that take up space. So if I wanted to draw a B, what does it look like? Is it one field called I? Is it two fields called I? Two. The super one and its own one. Right? It's just like the example we had last time. We have two variables with the same name. So we have two I's. We have the super I and the regular I. We have the AI and the BI. Let's call it that. And this is filled in with 1, and this got filled in with 2. Okay. We're going to call the super f function. So will that call this function or this function?
No.
This one. Okay. And what will this one do? This one will return I.
So one.
Which I?
The one.
This one?
Yeah.
Yeah, because that, from this class's point of view, that's the only I it knows about. So it's going to return a 1. So this will become a 1. and then we're going to add to that the value of I, which I is this. That's the bottom one, that's this I. So this equation right here, this becomes 1 plus 2. So this becomes 3. It gets written into I, which I?
B.
The bottom one.
Yeah.
Right, because that's really the only one. If we don't cast it to the top, the type A, it always defaults to B. So it's like this. From B's point of view, I is always B, the one that B added, unless you explicitly say the super I, or you have to somehow refer to the other one. So this result of 3 will get written to I, which is this one. So this becomes 3. And now we return super F.
Can we just write return I, and that would be the same answer?
Well, if we just said return I, a 3 would come back, right?
Yeah, that's what we wrote there.
Well, I think that whoever created this question, I didn't write this, I got this as an example, but I think they just wanted one more round of confusion. So they decided to take super's F. What is super's F? That would be this function which returns I. From this function's point of view, I is this field.
Right.
So this returns a 1. This returns a 1, and this value I is the 3. So this adds up to 4. I think it was confusing, and I don't think this added another round of confusion. It's kind of the same computation again. But this X would become 4 after this code ran. And it's just one of those, it's one of those examples where you just, you run around and you just got to follow it. In other words, when you're referring to this function, do you mean the F here or the F here? When you're referring to I, do you mean the I in the superclass or the inherited class? So this would end up, the value of X, which is a separate piece of storage, would end up being 4 at the end of this code. Okay. And then one last topic on inheritance is the concept of suppose we had an object like a circle, and then we could have other objects like squares and that kind of thing. So suppose we had a circle. We're designing our classes. Now I'm going to draw like an inheritance map. But suppose we had a circle, which now graphic circle derives from. And let's say we had a square, and what other shapes are there? Triangle. Yeah, let's say triangles. And suppose we wanted to have and then, obviously we can have graphic triangle and graphic square, right? Same idea that you could have the outline and the fill. Suppose we decided that these shapes all have something in common. They're shapes. So suppose we decided to call them, suppose we decided to have a class called shape. And make all of these 3 classes extend from shape. So what would shapes have in common? Like, what would all shapes have in common? They might have a function like, well, is there anything you can think of?
Sides, area.
Okay, yeah, an area. Yeah, maybe let's just say, and I think we talked about is a parallel line, like does everything have to have an enclosed area to be considered a shape? I think we decided, let's do that. So we could have like a circumference. Every shape should have a circumference. So what we might want to do is this. Suppose we wanted, like we've already defined a circle, but we decided anybody who adds to our system that defines a shape, we want to guarantee that they have to supply a function called area and circumference. Let's say every shape must have an area and a circumference. What we can do is we can create a class called shape, like this. Let's see. I'm going to leave a little space here. And then we'll add a public, I'm just going to leave a little space here, area. No parameters. And a public circumference. And close it out. Now, what have we done? And don't worry yet why I put some space here. There's just a word I want to write in. What have we done? We have guaranteed that there would be an area function and a circumference function given to all three of these because they all inherit from it, so they get a copy of every function and every data field for free. And then anyone who inherits from that gets a copy, everything gets copied down, gets inherited down. But suppose we wanted to require that the creators of the triangle and the circle and the square are required to fill in the rules. Because remember, they all have different rules on what the area is. Right? A circle is pi r squared, and a square is base times height, and the triangle is whatever that rule is, right? The base times the 1/2 base on whatever the rules are. So they all have different rules on how to calculate the circumference and how to calculate the area. But suppose we decided we want to make sure they are forced to supply those. Maybe we're going to have an array of shapes and we're going to run through them all and print out all their areas. And we don't want some of them having no function. You don't want to get an error, no function defined and all that stuff. So what we can do is we can create a concept called an abstract. And we'll use a different color to highlight the word. We can call an abstract function with abstract methods. What does this mean? Well, shape is a class, but it's an abstract class, meaning nobody will ever create one of those objects. We only create these things. Then why have the class? Well, it forces all the classes that inherit from it are going to be forced to write these methods. Because if you don't write this method, then you will never be able to create one of these objects. So that's what an abstract class is. You would use an abstract class if you have a bunch of classes that all seem to have something in common. And you would like to require that certain fields or methods be put in every one of those. You could then have an abstract class on top that they all inherit from, and then you could put abstract, and you could also put non-abstract methods. If there's some method that you want to define its body here, you could do that. But when you declare that a method is abstract, it doesn't have a body. You're forcing the code of that function to be in the lower classes. So this will have a design advantage in some of the programming examples we go over.